All right, you guys. So we are looking at almost our last topic for statistics. Okay. And what we're going to be looking at is um, a simulation. And what I mean by that is that rather than telling all of you to go out and to do a survey yourself and then come up with the data and analyze the data, we're just actually going to utilize a simulation here on the computer. Okay. All right, so what it says here, it says at a high school with 900 students, 900 total students, the true opinions of the entire student body on whether they approve of the student council president are shown below. Follow the directions below to determine a confidence interval for a sample of size 131. Okay. Now, what I really like about what Delta Math has done here is they're going to walk you through each step, and you don't progress on to the next step until you've gotten it correct. Okay, so you're guaranteed to get your problems correct if you go through each step. All right, so what I'm going to do here on the left is I'm actually just going to keep track of the math that I'm doing. You've already learned how to do the math. We're now going to put it all together. All right, so now let's see what we're looking at here. It says the population that said yes. So 432 kids said yes, they approve of the student council president. 468 of the students said no, they do not approve of the student council president. Okay, and then there's our population size of 900, which was stated up here in the problem. Okay. All right, so now they want us to calculate the population proportion who said yes, okay? So all I do over here is I take the people who said yes, so 432 people said yes, and I'm going to divide that by the actual population, which is 900, okay? So I just take 432, divide it by 900, all right, and so I get 0.48. Okay, so now I'm going to type that in here. So 0.48, try. All right, so that's a good indication. If I had not been correct, if I had been wrong here, then a message would have popped up on Delta Math giving me another explanation on how to calculate that. All right, now it says to calculate the margin of error for a sample size of 131. Okay, so now I'm going to bring back that formula, MO, that said 2 times the square root of p with the caret over it times 1 minus p over n. All right, so I'm going to redo this formula that we did in a previous video. All right, so let's plug that in. 2 square root, okay? So 0.48, okay, that's the number of people who said yes. So 0.48 times 1 minus 0.48. Okay. All right. Now here's where we're going to make a slight adjustment. Okay. So now we're going to look at just a population now of 131 students. This ratio up here does not change. Okay. We're just picking out 131 of the students. Okay. All right. So now I'm going to calculate that below. Now I'm on my graphing calculator. And so I'm going to type this in stages. You are welcome to use Desmos, but I don't want to flip between the screens. So I'm going to type in what's underneath the radical first. And if you're using a graphing calculator, this is good practice. So 0.48 parentheses 1 minus 0.48. So there's the value for my numerator. I'm going to divide that by 131. So that value is what's underneath the radical, okay? So if I were to write that, it would be 2 times the square root of 0.0019, and it would keep going. Now, calculators, I don't like to round in the middle of my problem, okay? So I can actually store, okay? I've actually got it stored here. So if I type 2, and then I type square root, okay, instead of having to retype that whole decimal in, I just type second answer. And there is my margin of error. And if you want, you can use Desmos like I taught you yesterday or the day before. So 0.086. 7. I'm going to cut it off there because it said round to the nearest thousands. All right, so 0.087. All right, now I need to come up with a confidence interval. All right, so now I'm going to use this piece of information here, and I'm going to use my margin of error. Okay, and it's really simple. You're just going to take 0.48 and you're going to subtract 0.087. You're also going to add 0.087 to both sides. And that's what's going to give you that confidence interval. All right. So if I take 0.48, and I subtract 0.87, that gives me 0.393. And then I'm going to take 0.48, and I'm going to add 0.087. So that gives me 0.567. All right, so these two values create my interval that I'm going to type in here. So 0.393, 0.567. Now I'm going to click try. Okay. Now, what we're going to do, okay, and this is where we're going to run a simulation, okay, and it says hide all the opinions. So, all right, click hide. All right, now it says to shuffle. So you can see down here, it is shuffling all those opinions. And if you looked at it before, all the yeses were listed first and all the nos were listed at the end. Okay. All right. Now what it's telling you to do, it says to click on each individual circle to sample the student or hold down your mouse and drag over several at a time. Okay. All right. So what we're going to do is we're actually going to run the simulation of picking out 131 students. So you can click one at a time, and you want to click all over the place because that's what would happen if you were to pick out just 131 students. Or you can just hold your mouse down, which is easier. Just move it all over these yes and no's, okay, until you get 131 selected. You can see it's up there. See how it's counting them up? So I'm only at 84. All right, let me get some over here at the bottom because they're all shuffled up. So it'd be like I was drawing names out of a hat. Okay, so now I've completed it. So now I have actually, on my own, randomly selected 131 yeses or nos. And it tells me that here I sampled 60 kids who agree with it and 71 kids who are at no. And my sample size is 131. Okay, so it says sample proportion for who said yes. All right. So now I'm going to go here. And I'm going to say, all right, I had 60 kids who said yes, and my sample size is 131. So 60 divided by 131, that gives me 0.458. So I'm going to round to the nearest thousands. So 0.458, and I'm going to click try. All right, now it's going to ask me a question. So I did all that work before, so why did I do it? Okay, so now is this number that we just got, is it in the confidence interval? Okay, and if you can tell 0.45, yes, it would fall in between these two numbers. So I'm going to click yes. Okay, it says you are finished. Press submit to get credit. Okay, so what you've done now is you've ran a simulation. Okay, you did the calculations first and then you ran your own test. Okay, and now we're going to hit submit and then you click yes. Okay, all right, and then you've got some information here on how we did the problem as well. Okay. All right, now what I recommend, okay, it doesn't matter if I do one of these or if I do 10 of these, those steps are going to repeat themselves. Okay. What I'm giving you is the opportunity is not to have to go out and tell you and say, hey, you're going to go poll every kid at URHR High School and you're going to ask them this question. And then we're going to do some data checking on there. Okay. You get to kind of skip that step. Okay. So you're going to have 5 problems where you get to practice going through these steps. What I recommend you do, okay, is that you rewatch the video, organize your notes however you would like, okay? Because we've already done all this, we're just putting it all together, okay? And then I would rewatch the video, and also too, you might have the video playing on your phone while maybe you're watching while you're trying to do a sample problem on your own, okay? All right, if you've got any questions, let me know. You know how to contact me.